Let's take a look at graphing on a TI-84 Plus Silver Edition. What is a Plus Silver Edition? That's kind of questionable. This may be one. They'll all say this across the top. If I do a second button and then the plus to get to the memory, there's an about here. So if I press the enter on that, there's a Silver Edition, but then there's a MP, which stands for Math Print. So if yours says MP, then you're set up for Math Print. What does that look like? Well, if I graph certain items over here, then they'll look different than a normal TI-84 Plus Silver Edition. So it's a little bit confusing. I'm going into mode here, and I'm specifically in this video going to show you just a straight TI-84 Plus Silver Edition. So I'm going to down arrow, and I show this to you so you can see it. And on the second page, you see it says Math Print and says Classic. Now mine has Classic highlighted. So if you're trying to follow along with this video and you got that MP version of your calculator, again, press Mode, down arrow until you get to this, right arrow, put your flashing cursor on Classic, and press Enter one time. Now to exit out of anything, you do a second mode. And now this is just a straight TI-84 Plus Silver Edition. So let's take a look at our different building blocks. We're going to take a look at y is equal to x. Now these are pretty simple graphs. You may already know what it looks like. The key here is learning all the different building blocks. So make sure you understand how to plug in each one of these, because later on we're going to combine these together into harder graphs. Okay, so y is equal to x. I press my y equals, press my clear. My x key is this xt theta little n, so I'll push it. And then I'll press my graph. And that gives us our answer. Now you may have had trouble getting that. Say you got an error. I'm going to show you the ways to fix your graphing calculator when it gets an error. Now the steps I'm going to show you will fix probably 95–98% of all the problems you'll run across. Let's go to y equals. You can go freely back and forth between y equals and graph. So if I press graph, if I go to y equals, again you can flip back and forth. Across the top you see it says plot 1, plot 2, and plot 3. I'm going to up arrow and put my flashing cursor on plot 1, and then I'll press enter one time. And then I'll down arrow. So you see now plot 1's highlighted. Now one of three things will happen when we push the graph. If I push the graph here, this time we get an invalid dim. That's one of the things that will happen. Another thing that will happen is it'll just work. You'll get the correct graph. And then third thing is you'll get the correct graph, but there'll be extra garbage on the screen, like extra boxes. I'll press enter on the quit here. I go back to y equals. We don't want any of those highlighted. Those are statistics functions. So I'm going to up arrow, put my flashing cursor on plot 1, and press enter one time, and then down arrow. And now if you press graph, you should see it work. Okay, if I go back to y equals, you see I got y1 through y7 on the screen. If I down arrow clear to the bottom like y0, occasionally a student will come down here and they'll put garbage on here. A bunch of commas, a bunch of parentheses or something like that. Something that isn't valid. They go to graph. Negative syntax error. Well, quit is highlighted, and your natural inclination then is just to press enter. And you think, well, that's weird. You go back to y equals. It's like, looks pretty simple. It doesn't get any simpler than that. And you think, well, maybe it's a quirk. Let me try it again. You press graph. Now it's working. And oops, there you get another syntax. What you should always choose, you should choose go to. So I'm going to down arrow to go to. I think it took. There it goes. Finally. Try it again. There. A little trouble with the emulator. Once I get down to the go to, I'll press enter on it. And it'll go to where the error is, which is down here. Now when students come up and they have this particular issue, and I see this, I ask them if they have kids. And some of them will say no. And then I'll tell them to quit drinking while they're using their calculator. I couldn't figure out how else they could get garbage down here on the Y0 like that. Then I had a student one semester, she explained she throws her calculator into her backpack without putting a cover on. And then I could understand it. But either way, press clear, it'll clear out that garbage. And then if you press graph, it'll be working. The third thing, occasionally you get your windows screwed up in some manner. Zoomed out, zoomed in, zoomed to the side. To set it back to your standard viewing window, which is -10 to 10 on the x-axis and the y-axis, we'll press zoom, and you press 6 for Z standard. So zoom 6. Mine was already at Z standard, so you don't see it. One problem this fixes is some people go into Windows by accident, and they'll type in numbers here. I could put 20 in for X min, and X max is 10, which is incorrect. So when they go to graph, it gives them window range error. Well, if you do enter on the quit, again, go back to zoom, choose 6. That zoom 6 is probably the most popular item to fix mistakes on your calculator. The plot 1, plot 2, and plot 3 probably comes in second, and then the last one comes in third. So those are the 3 most popular ways to fix your calculator. Let's look at our next building block. We've got y is equal to x squared. Well, I'm going to press my y equals, press my clear, I'll do my x key, and then we'll push the x squared button, and then graph. And that would be our answer. Well, let's look at y is equal to x to the third. Now I could care less what this graph looks like. I'm demonstrating how do you handle it when you got any number up in your exponent. You got a 3 up there, 4, 5, 20, 201. So we're going to do y equals, clear, x key, caret, 3, and then graph. And that'll be your answer. And let's take a look at how you do y is equal x to the 1/2. And I could care less what this one looks like. I'm demonstrating how do you handle it when you got any fraction in your exponent. Even more than this, if you ever have more than a single number or a single variable in your exponent, the key to it is to put parentheses around the exponent. So as we plug this in, we want to put parentheses around the 1/2. Other than that, everything remains the same. So I press y equals, press clear, I do my x key, I do the caret for the exponent, beginning parentheses, 1 divided by 2, closing parentheses. TI-83, TI-84 is very forgiving about closing parentheses at the very end. I'll always put it there for completeness sake. So beginning parentheses, closing parentheses, then graph. And that'd be your answer. Well, our next building block is y is equal to square root of x. So press y equals, press clear. Now, some things are on button, some things are above a button. See my x squared button here? Above it is a square root symbol. So to get to that, I press my second button one time, and I push my x squared. And it puts a square root and puts a beginning parentheses. So then I'll put my x key, closing parentheses, and then graph. And that'd be our answer. You'll notice it's the same graph as what we just came up with over here, and it should be, because x to the 1/2 is the same as the square root of x. Cube root of x you run across in algebra. So let's take a look at it. I'm going to press my y equals, clear. If it's not on a button, if it's not above a button, you're going to find it underneath the math button. So press the math button. And you see the cube root is our 4th one. So I'm going to press 4 to choose it. It puts the cube root, puts the beginning parentheses, so I'll put the x key, and I'll put the closing parentheses, and then graph. And that's our cube root of x. Okay, let's take a look at the 4th root of x. Now I could care less what this looks like. I'm demonstrating how do you handle it when you got any number in that slot. This slot is called your index. So here our index is 4. Now we already covered square root, which is index 2, and cube root, which index is 3. So this is where you got 4 and above. You could have 5 in there, you could have 20, you could have 201. So fourth root of x. I press my y equals, press my clear. You always put your index in first. So I put the 4 in. Now I go into my math button. And we want to choose this, the fifth option, the radical with the x as the index. So I press 5 to choose it. Now it does not automatically put a beginning parentheses, so we want to put that always. And then I'll put x in, and I'll put a closing parentheses, and then I'll press graph. Kind of looks like the square root, but it's a little bit closer down to the x-axis. So it looks like that. Now you may do that problem without putting a parentheses, and then you think I'm full of it. You don't need a parentheses. And that's true when you got a single x here. But when you get more complicated items underneath the radical, have to have the parentheses. So it's always a good practice to start off by putting a beginning parentheses there. Now absolute value of x. Press my y equals, press my clear, I go to math, and then I'm going to right arrow to num, and ABS is our first choice. It's already highlighted, so all I have to do is press enter. And notice it puts the ABS and puts a beginning parentheses. So we'll put our x in, put a closing parentheses, and then graph. And gives us our V-shaped graph. Now our next one, we've got y is equal to x minus 2, no, I'm lying to you, x plus 2 over x minus 3. I could care less what this looks like. What I'm demonstrating here is how do you handle it when you got more than a single number or a single variable on top and bottom of your fraction. Well, up here we got more than a single number, a single variable. The trick is you put parentheses around that part then. Same down here, so we'll put parentheses around the bottom part. Other than that, you type it in exactly as you see it. So press my y equals, press clear, do a beginning parentheses, x plus 2, closing parentheses, divided by beginning parentheses, x minus 3, closing parentheses, and then graph. Probably what you'll see is that and just sketching it. I'm not spending a whole lot of time on that. Like that. Occasionally, some of the older TI-84s will have an extra vertical line here. That vertical line is never part of your graph. I used to think that they put the vertical asymptote on there as a feature until I went to TI's website and read, and it's a flaw with the calculator. So that vertical line should not be there. Now in my particular emulator here, I didn't have it, so I'm fine. Okay, let's look at this problem. Y is equal to dash square root dash x dash 3. Now in our calculator, we got two dashes. The one on the bottom row here, which is a negative, and the one on the side here, which is a minus. If your dash is at the very beginning of whatever, then it's a negative. So this dash here is at the very beginning of our problem, so this is a negative. This dash here is at the very beginning of our square root, so it's a negative. And this dash is between two items, and when it's between two items, it's a minus. Now you might argue that this dash here is between the square root and the x, but that goes against our first guideline. If it's a first item in whatever, first item in square root, first item in the problem, first item in absolute value, first item in whatever, it's a negative. Other than that, we're going to type it as we see it. So I press my y equals, clear, put in my negative, square root, so I do second x squared, negative x minus 3, and I'll put a closing parentheses to finish off the square root, and then graph. And that would be our graph. Let's see what happens if we put the wrong dash. I'm going to go back to y equals, and this dash that's before our x, I'm going to change it to a minus, and then press graph. We get a syntax error. Well, that's okay. We know how to handle syntax errors. We always choose go to, so I down arrow to go to and press enter. Now, it not only goes to the line where there's a problem, but actually puts the cursor on where the problem is. And so you see the flashing cursors on this dash, so it must be the other dash. So it's a negative that goes there. Well, and then I graph, and it works. Well, if the calculator will tell you if you put the wrong dash, what's the big problem? Why do we focus on it so much? You go back to y equals, instead of that minus there, let me come and change that to a negative. And then press graph. Now all of a sudden, instead of getting an error, we're just getting a wrong graph, which is frustrating. Come test time, come final exam time, you think you did everything perfect, and you miss that problem completely. Very important you know what dash is what. And when it's between two items like that, then it has to be a minus. And you can see then it flips it clear over there and even changes the general shape of it. Okay, now let's look at a problem where we kind of merge together different building blocks. So we got x to the x squared minus 3x plus the square root of x power. Now remember, the trick to these were with the exponent. If you got more than a single number or a single variable in your exponent, you had to put parentheses around the exponent. So as we plug this in, we want parentheses around the exponent. Other than that, we type it in as we see it. So press my y equals, press my clear. I do my x key, caret for the exponent. And remember, we said we want parentheses around the exponent. So I'll do a beginning parentheses, then x squared. So press my x key, x squared, minus 3x, plus the square root of x. So I'll do second x squared, and it puts a square root, puts a beginning parentheses. So I'll put the x. I'll put a closing parentheses for the square root and closing parentheses for the exponent, and then press graph. And that'll give us our answer, or as close as we can get with the graphing calculator. That may not be our true picture. Graphing calculator is wonderful, but it doesn't always give us everything we need for the graph. We don't worry about that. If you're curious, when you go on to calculus or business calculus, if you are going to those classes, there'll be a whole chapter of how do you find the true picture of the graph. We're happy with basically what we see on our standard display, typically. Okay, let's say you're not really into all this technology. You love plotting points. You're the best point plotter there was in your class. Everybody else was happy with 3 points. You had to have 10. And you plot these. Well, we know what that looks like. That's that parabola. That's that U-shaped graph. Looks like that. Or is it? Maybe it's coming up like this and looking like this. It's the heart shape. Maybe it's coming up here and then coming back down over here. Maybe it's coming up here and coming back down over here. Maybe where this is coming down at is at x equals 500. So you just needed to plot 500 points and you would have saw it come back down. Plotting points is a horrible method. It only works if you know what the graph looks like to begin with. Well, if you know what the graph looks like to begin with, why are you even graphing it? Graphing calculator is a much better tool. It's not perfect. Again, calculus will give you the precise graph. Because remember, our standard viewing window could look like this. And then we have no clue it's coming back down. Now later on we'll see how to use the leading coefficient test with the graphing calculator to try to understand better what happened with your picture. And this was graphing on a TI-84 plus Silver Edition.